Hi, I'm Professor Ricardo Rabelo, full professor at UFSC and the general coordinator of the Automation 4.0 project. Automation 4.0 project is actually one of the 27 UFSC sub-projects in the scope of the national program PRINT. Automation 4.0's fundamental goal is to establish, strengthen, and foster international cooperation as a means to improve and to consolidate our knowledge in the general area of Industry 4.0, mainly in the manufacturing sector. The Automation 4.0 project focuses on control theory, automation, and computer science directly to the following sub-areas: artificial intelligence and agent-based systems, intelligent and autonomous cyber-physical systems, including robotics, Internet of Things and Industrial Internet of Things, industrial networks and wireless communication, industrial instrumentation, process control, embedded and real-time industrial systems, service-oriented and cloud-based systems, big data, and related middleware, and systems integration and interoperation. The project is composed of professors from UFSC and a number of international institutions. At UFSC, we are about 40 professors from 3 graduate programs, namely Automation and Systems Engineering, which leads the project, Electrical Engineering, and Computer Science. Internationally, our network currently involves 38 high-level professors from 30 universities of 14 countries from North America, Europe, and Oceania. Besides the research itself, expected outcomes from this wide cooperation in Industry 4.0 includes better people training at undergrad and graduate levels, creation of a stronger students' entrepreneurship culture in the form of startups and spin-offs, and to improve our technical expertise towards strengthening the cooperation with industry and the innovation ecosystem. You are quite welcome to join us.
My name is Vania Bugorni. I am the head of the Computer Science Graduate Program, and I am the coordinator of the sub-project Big Data Analytics, sending light from the gene through the cosmos. This project has as objective to develop new algorithms for big data analytics, for applying on several different application domains, going from biology to physics to any kind of domain. In the last year, we achieved several good results. We offered 2 courses in English, one in biotechnology and one in computer science, as our project is together with the biotechnology. And we organized a workshop with 4 international partners involved in our project. We have 3 PhD students that are in a co-tutela process with CNR Italy, and we had 2 missions with professors that started a new collaboration with international professors from Canada and United States. We have 1 student that went for a sandwich program, and so far, we are very happy with the results and the cooperation between computer science and biotechnology.
O título do projeto é Internacionalização da Matemática e Integração com Física e Engenharias. Coordenador Daniel Gonçalves. Tema é o 5, Transformação Digital, Indústria e Serviço 4.0. Programas de pós-graduação participantes, Programa de Pós-Graduação em Matemática Pura e Aplicada, que é o programa líder desse projeto, além dos programas de pós-graduação em Engenharia Elétrica e Engenharias de Automação e Sistemas. Esse projeto tem como objetivo principal a internacionalização do Programa de Pós-Graduação em Matemática Pura e Aplicada da UFSC, além da sua integração com outras áreas de conhecimento, principalmente Física e Engenharias. Para atingir o objetivo do projeto, é importante uma constante colaboração dos grupos de pesquisa do projeto com pesquisadores do exterior, líderes em suas áreas de pesquisa. Os assuntos a serem estudados são voltados a problemas atuais, importantes para a evolução do conhecimento em matemática, e também nas aplicações em áreas afins. São diversas instituições parceiras desse projeto, em países como Alemanha, Austrália, Áustria, Canadá, além de Espanha, Estados Unidos, França, Itália, Japão, Suécia e Suíça. São centros com vários pesquisadores renomados na área de interesse do projeto. Aqui eu destaco algumas bolsas que foram implementadas em 2019 e 2020 ou que serão implementadas no próximo ano. Bolsas de pós-doutorado sanduíche, bolsas de professor visitante no exterior ou bolsas de pós-doc. Como resultado direto desses auxílios, foram vários artigos publicados, grupos de pesquisas formados ou consolidados, além de uma melhora significativa na qualidade de teses e na formação de alunos dos programas de pós-graduação envolvidos.
In this short video, I will present the Encanto project, analysis of distributed and automated manufacturing of customized items. This project is part of the Institutional Internationalization Program, PRINT, supported by CAPES and executed by UFSC in close collaboration with its international partners. The project is located in Team 5 of this program, Digital Transformation, Industry and Services 4.0. The motivation behind the project is very clear. We have advanced manufacturing, new manufacturing systems, processes and technologies. We have the fourth industrial revolution. We have hybrid physical systems, the close proximity between virtual and physical worlds. We have Internet of Things, mass customization, intelligent production logistics systems, supply chains 4.0. In this context, the project aims to analyze the operational, economic, and social viability of implementing an IoT platform for this distributed and highly automated manufacturing for customized items. This platform would connect the design phase, the manufacturing phase, and the product usage phase of a specific customized item. This project comprises funds for the international mobility of faculty and students. Opportunities, research opportunities in the scope of the project. We can mention the modeling of such IoT platforms for the integration and synchronization of distributed production systems. The use of digital twins to evaluate the performance of this distributed and highly automated manufacturing. The developing of decision-making models and methods that are suitable for cyber-physical systems in the context of the integrated design and manufacture of customized products. Improving healthcare 4.0, consider distributed manufacture of these customized items for medical treatment. Analyzing production logistic intelligence systems and supply chains 4.0. The partners in this project are located at UFSC in the graduate program in production engineering, the graduate program in computer science, and the graduate program in accounting. The international partners of this project are located in several countries, in Europe, in the United States, Canada, also Chile. So we have a broad spectrum of international collaborators, partners, acting in the scope of Encanto project. So this was my aim of this short video, presenting the aim of the project, the opportunities comprised in the scope of the project. If you are interested in getting more information regarding the project, you can access our webpage. There you can find more details about the project, the scope, and the opportunities. Thank you very much for your attention.
Alexandre?
Sim, professor Ricardo, o senhor está como apresentador.
All right. So let's start. So I'd like to ask the panelists to open their cameras so that everybody can see you. So before starting our session, I'd like to welcome to everybody in this session. So be very welcome to this event in the scope of digital transformation. So the main subject of this event is actually twofold: to discuss the needs and the skills that current and future engineers are required to have to more effectively help companies to handle the challenges brought up by the Industry 4.0 and digital transformation, and how engineering courses in 21st century universities could or should be somehow transformed accordingly. So this event is organized into two parts. In the first part, there will be a plenary talk of 20 minutes to be given by Professor Klaus-Dieter Tobin from Germany. After him, 4 panelists will also give a talk. They are Professor Luis Camarinha Matos from Portugal, Professor David Romero from Mexico, Professor Birajara Moreno from UFSC, and Professor Enzo Frazon from UFSC too. This initial part is planned to take about an hour. In the second part, these panelists will start a discussion between them about their visions and experiences, where the public can also participate by sending questions via the YouTube. Questions can be written in Portuguese, if it was the case. This is planned to take about 30 to 40 minutes. On behalf of our university, we'd like to thank you very much for having so kindly accepted our invitation, as well as for having booked some time to share your visions and knowledge about a problem Brazil so much needs to improve to face the challenges brought up by the 4th industrial revolution we are currently crossing. So hope you enjoy that. So from this moment on, I'd like to invite Professor Klaus-Dieter Tobin to share your slides and to start your talk.
Can you see my slides?
Not yet.
Sorry. Can you now see my slides?
Yes, you can.
Yeah? Okay. Yeah, thank you very much, Ricardo Robello, for this introduction. So this is my first presentation where I don't have a clear title on, because I got an email where Ricardo asked me to talk a bit about the needs and skills current future engineers are required to have to more effectively help companies to handle the challenges brought by the Industry 4.0 and digital transformation, and how engineering courses themselves could be transformed accordingly. And in another sentence, he said, I can also provoke the audience, and this is my main message. So I don't have a clear, let's say, message in terms of a clear idea about how a curriculum should look like. I have many ideas and I want to share this with you. And I don't have a clear, let's say, concept which I want to sell regarding the needs from the industrial perspective, but also from the engineering students' perspectives. So my background is engineering. We have together with a colleague, I'm leading an institute which is linked very much with Industry 4.0 issues, and we have actually about 180 employees. And you see the topics of the two research groups. One is intelligent production and logistics systems. The other one is ICT applications and productions. And you can imagine that most of our projects are dealing with the topics of today's session here. So In our institute, we started right up from the beginning to focus not just on the technology. This will be also part of my talk, because I think we have to consider organizational issues, technology issues, methodological issues, as well as qualification issues at the same time. And we should not anymore focus on isolated topics like technology, especially the lessons learned from many projects we have with medium-sized companies here at BIBA. We have learned that we need an integrated and holistic view in all the things we are doing also with industry. So I will start with slides some of you already know. This is just to make modifications. So this is a concept we developed years ago, but it's still valid, and it's not yet fully adopted by the industry, because in the past companies were providing parts and simple products. Now we have to provide benefits and profit for companies. And this can be achieved by providing extended products, as we call it, or a better known term is product service systems. And this is a big change, which has been discussed in academia for years. But if you talk about these issues with industry, many people in industry still don't know what are the consequences and what is the impact for their work and for the structuring of their work. So an important element also which affects the industry is that in the past we had very, let's say, simple structured processes. You see it here on the left. We had structured and mostly linear standard processes, and this has been transformed meanwhile to what we call semi-structured cooperative complex processes. And this is again very, very challenging for many people to understand and to imagine the consequences which this have for their daily work and also for their future. And the next slide shows how the companies were transformed in the last years, or let's say in the last decade. So for years we had very simple, stable socio-technical systems. Now we have to deal with complex, unstable socio-technical systems, and which we call ecosystems. Again, many industries, especially medium-sized companies, they don't understand what does it mean for me? What is the consequence for the design of our organization? So one example. Here you see a tractor on the left side, and this tractor has been transformed. And if you see the big tractor providing companies, they have transformed their business to smart products and to connected products. Now they have to offer, or they have to provide a system which is an element of a so-called product service system and a system of systems, and the tractor is just one element out of this. And here you see the complexity. And complexity is a very, very big issue, and especially if we deal with students. And we learned that this type of complexity is a big challenge for companies, but we also face the problem that this is a big, big issue for our students. And the next slide shows, just as an example taken from a European project, where we had the goal to build an IoT open innovation ecosystem for connected smart objects. And we had car manufacturers with us. For example, BMW was with us, Volkswagen was with us, and many other companies. And it was a big challenge for all the different members in the project, mainly engineers, to really understand the complexity of all these elements in the ecosystem. And to my understanding, we have to deal with this complexity because this will be a big challenge also in educating people, but also in transforming the industry. So I just take here one example. I'm not going into any details. So it's very difficult if we talk about the future of engineering curricula? What are the right topics we have to teach? So I just take here one example, how to make products smart and using big data. So this is an isolated topic. We have classes on this, and we can train students in using some of the methodologies, in applying some of the tools. But what is the value of this knowledge later on? And this is more and more challenged today. So here is a slide showing sorry, but my screen is a bit, I can't see everything. Okay, so the most attractive employers for engineering students. So I checked the internet. So what are the most attractive employers for engineering students in the US? And what a surprise, all these big names. So we had the same in Germany. What a surprise, all the big names. So, but we are talking about medium-sized companies. And this is a big challenge because many of our students, they even don't have a clue what are the companies, what are the names, what are they doing. And here's another slide. Unfortunately, I have only a German version. And this is very special, maybe for Germany. The majority of the engineers and the majority of the workers in industry are not with the big names. In Germany, we have a very strong medium-sized companies. Medium-sized in Germany is, as we understand it, is between a turnover, yearly turnover between 50 million euros up to 3 billion. And we have many of these so-called hidden champions. So Germany is full of medium-sized companies which are completely unknown to public and completely unknown to students. And just a few of them are a bit bigger, let's say, and provide products in the B2C market. The strength of the German industry, for example, is very much in the B2B. So this is not at all visible. And so the problems of these companies are not visible for students. And this is a big challenge, what we faced also in our education meanwhile. So is there still a one best way? When I was a student, and the professors, they told me when we were asking, so what should I do? So what about making a career? Oh, that's very easy. You should visit all my classes. You should make your master's thesis and your bachelor's thesis with my group. And then you will apply with this company, and then it's a job for lifetime. This is gone. This is gone forever. And this does not exist anymore. So if students are asking me as a teacher, as a professor, I can only say, I don't know your future. I don't even know the future of our institute. But I know that we can prepare ourselves for this future. And this is the biggest challenge which we have to face. And and again, something which is maybe typical for Germany, this is always this balancing between theory and practice. And this is an ongoing discussion we have in Germany, but I will come back to this later on, because there are many facets. So in Germany, we have a long tradition, maybe some of you know this, we have so-called dual education system, which is the backbone of the highly qualified workforce in our industry. And dual education means that people, even if they decide to leave school, they still have to go to school, but in a different way, and because they have classes in parallel to their apprenticeship up to the age of 18. And this is still very attractive for many people. And as the entire system is becoming more complex, we have also designed a so-called dual study. This means you make an apprenticeship in a company, for example, in mechanical engineering, but in parallel, you're studying mechanical engineering. And this is under discussion because what is better? theory or practice. So those who are the promoters of this dual education, which are mainly the industry, this is not academia, but mainly industry, they say, yes, these are the people we want to have. These are the people who know how we work. And I would say, yes, they are right. But these are not the people who will directly transform these companies or who will create the futures. So it's then other countries, other manners. So I think it's important to look very carefully into the systems in your country and what are the real needs in your country. I don't think that there are, let's say, unique needs which are similar among all the different countries. And another issue is generalization versus specialization. Responsibility in teaching and training, short-term versus long-term. What is the responsibility of the learner? Is there a responsibility? Is there a responsibility for, of the employer? For example, in these days, we have an ongoing discussion. You know, in Germany, we have very strong trade unions, and there is an ongoing discussion who is responsible for the qualification of the workers and even the engineers, which have jobs actually, and who is taking care about their future. And you can imagine there's a high level of momentum because especially during this pandemic, there are different stakeholders in the discussions, the trade unions, the companies, the big companies, the small companies, the state. What is the role of the state in this system? And this is, nobody knows exactly what will be the outcome. So I had a look into learning, and I found these let's say 4 pillars of learning defined by the UNESCO. And I like it very much because this opens the minds for learners and also for people who are educating people. So there are, I will not go into the details. We can share the slides later on. What is important is there is learning to know. And maybe this is partly forgotten in some of our programs. And learning to be. The content which we have to train people or which we have to educate people with is far bigger than just the problems which we are facing actually in the industry. But I will not go into detail on this because I'm an engineer and I will stay to my my field of competence. So I was looking for some slides which map more or less my ideas in future education of engineers. And maybe some of you are familiar with this initiative, this CDIO initiative. And this was launched between MIT and Swedish universities already years ago. But it's a growing worldwide community. There's a lot of information on this on the internet. And what is important, this is very much on project-based learning, including academics from industry, engineers, and students. And in the German engineering education system, we are practicing this already for 20 to 30 years. So this is already part of our education. So I looked at the countries and the universities who have adapted this system. There are only 3 German universities, 2 high schools and 1 university who are members of this initiative. I think the reason is that this is very much in line with things we are practicing already for many, many years. And what is important for us as well is students construct their own knowledge in this framework. And what is interesting here is they are also talking about the complexity. Sorry, I think I missed to explain this CDIO. C means conceive, D means design, I means implement, and O means operate. So the idea is to cover the entire life cycle from the very beginning to the very end. This, of course, leads to many questions which cannot be answered very easily for the students. So they offer courses where it's implementation and operation, and this is what in many cases is the focus of courses at university level, then what is important to my understanding is to link the design, not in a narrow understanding of designing, and this is important. What is the purpose of the things students are doing? What is the impact of this? And then the next level is also to integrate the first step, which is conceive, which means to plan these systems. And only by this complex perspective, people can gain a holistic understanding of the, let's say, complexity, what is Industry 4.0 about, and what is meant by these product service systems. So just a link, I participated in a conference where I got, where I saw a very interesting presentation from George Westerman, and there is a very nice article about the Transformers CLO and Chief Learning Officer. And what is interesting for me, the goals they are addressing here is from developing skills to developing mindsets and capabilities that help workers to perform well now and adapt smoothly in the future. This means we have to train people not just regarding technical details. I would say we are good at this. At least we in Germany, we don't have this problem in training people directly on specific matters. The challenge is to talk about the integration, to talk about the future, to talk about the transformation, and to provide information to the students. What is their role? So conclusions. One best way approaches, to my understanding, are too limited and will fail. So I don't believe in this overall, let's say, recipe how to train our people. And there will be no all-in-one engineer suitable for every purpose. This was the dream of the industry for many, many years. And we have to train people in terms of ecosystems instead of, let's say, this buzzword, one size fits all. And my last points are, what I learned also during this crisis is how to thrill, how to inspire young students for our topics, how to make them aware what are the real needs of industry. And there are many other questions of how to. I don't have an answer. And the last thing I want to mention is this is a very, very tough discussion we actually have in our faculty. And we have achieved, meanwhile, in the Faculty of Production Engineering, where I was a dean for the last 5 years, we have decided to make an entire redesign of our engineering curriculum. And we have already project-based learning, we have already all these elements, but most probably we will make a total redesign of all the engineering courses, of all the classes, and we will integrate, for example, mathematics, mechanics, machine elements into process-based learning, where we try to integrate and show the relevance of knowledge in mathematics, of knowledge in mechanics to the students by experiencing it right up from the beginning in the master course. And this is the message. I hope I have confused some of you. Hopefully I have also inspired some of you. Maybe you have got the impression that this is a hot topic also for me. This was my intention, and I hope that we have a very lively discussion later on. Thank you for listening to me.
Thank you very much, Professor Klaus-Dieter Zoben, for a very insightful talks and points you have pointed out. So you have the opportunity to talk about them later on. So then I'd like now to invite Professor Luis Camarinha Matos from Portugal to provide your talk. Thank you very much once again, Professor Luis Camarinha.
Well, I would like to see how to start my slides now.
Can't you see share the slide?
No, because it doesn't allow.
Alexandre,
Olá.
talvez tenha que dar passar o...
O professor Luiz está como apresentador.
Ok, yes.
Agora
Alright.
comecei.
Ok, thank you. Ok, Luis.
Do you see my slides now?
Yes, we do.
Yeah, good. So, first of all, thank you, Ricardo, for
O professor puder propagar a imagem, lá no YouTube a apresentação não carregou.
E como faço isso?
No botão de mais tem propagar layout.
Ok.
Sim.
Já dá para ver? Ou não?
Está carregando.
Está carregando. No YouTube.
Ok. Então, esperamos uns segundos para ver se funciona.
Ainda não, está carregando.
Então, na verdade, a câmera do professor também não está aparecendo. Eu vou retomar a apresentação e passar de novo para ver se carrega. Agora você está de novo como apresentador, professor Luiz.
Sim. E agora, carregou?
Está carregando.
E nesta plataforma vem os slides ou não?
Sim, na plataforma sim. No YouTube aqui ainda não.
Ok.
Chegaste a fazer aquele broadcast?
Sim.
Está carregando ainda. Ok. Agora
está.
Yes.
Huh?
Yes. Yes.
Okay. So sorry for this little delay. So thank you, Ricardo, for the invitation. In fact, it was to be much more pleasant if we could be in Florianopolis right now. But anyway, it's a pleasure to be in this panel. Let's see if this works now, the slides. So the topic that we are discussing about Industry 4.0 and digital transformation, in fact, these are terms that represent a convergence of initiatives and technologies that come from several years and that have been active in different parts of the world. But in fact, it became a very important movement for the industrial transformation in the last decade, or at least in the last 9 years. And as a consequence, we can also see that this became a kind of Me Too movement in the sense that many people or many sectors that were in different areas of engineering and technology, because of the the fashionable appeal of these terms, became very interested in claiming that they are contributing to Industry 4.0 and digital transformation and so on, which is important as a, let's say, a motivation to cause change. And when we see our politicians also talking about these topics, it is really motivating, because we need sometimes that some words or some buzzwords become very fashionable, so that this can lead to a real transformation. But as these terms become very popular, the topic that Ricardo proposed was also becomes more important. So what is the role of academia, universities, and polytechnic institutes in terms of education of future engineers, or transformation of the current programs that we have in the different fields of engineering? Of course, this is a very comprehensive or very extensive topic that we cannot address fully in this panel. So I took just a particular position, that is to address the needs, or some needs, for the digital transformation part of it. And from my point of view, in addition to what is the specific subjects addressed in each field of engineering, being it electrical engineering, mechanical engineering, industrial engineering, automation engineering, whatever, I believe that all of them, to be able to address challenges of digital transformation, they would require a good background in computer engineering. That means if we consider the classical three levels of education, that it means the bachelor level, the master level, and the PhD level. For instance, at the bachelor level, I would think that it is important to introduce to all engineering students some key topics that allow them to understand what are the bases for the digital transformation processes. This could include examples, real-time systems, digital modeling, cyber-physical systems, Internet of Things. And of course, all of these are supported by a reasonable background in programming and intelligent systems, artificial intelligence basics. Okay, the problem is, or the challenge is, that the introduction of these subjects and traditional engineering courses or programs, in fact will require some fights at the university level, because all traditional courses are of course full with their programs, with all the subjects that are there for many years, and it's not easy to find a place to introduce new subjects. So a big challenge ahead of us is that we do not have usually a blank canvas where we can design a new engineering program. So often in our departments, in our education institutes, we have to conduct these fights to introduce new subjects. But I believe that to prepare engineers for this digital transformation, independent of the area, they need to be educated in some basics of computer engineering. Then if we go to the next layer, to the layer of the master in engineering, I also believe, and in this sense, I agree very much with many of the aspects that Klaus Dieter just presented. I believe that it is necessary to provide future engineers with a systemic or holistic and integrated view, and an integrated view of all dimensions involved in Industry 4.0 and digital transformation. For instance, in this slide here, you can see 6 typical dimensions that often appear in the literature, and some of them are related to the infrastructures, of the industrial systems, and others are related to the product and the new visions of the products. So I believe that for all, it's important that future engineers have a good understanding of all these aspects or all these dimensions, and not just a partial understanding of one particular point. I also believe that it is important to give students awareness that the world is becoming very networked or hyper-networked. Therefore, we need to consider networks, and more specifically, collaboration among members of networks, which leads to the topic of collaborative networks, as an important pillar of all these dimensions. For instance, if we consider the first dimension, that is the vertical integration at the company level, we can observe a transformation from traditional monolithic systems or monolithic views of the different layers of the enterprise into a different view that is networks of autonomous, intelligent subsystems, intelligent machines, and humans all together in a network operation. So if we go to the horizontal integration, this is the more traditional view of supply chains, value chains, is where it is more obvious that we have networks and we have collaboration. If we go to the product, to the engineering, we need also to consider collaboration among departments, collaboration with the customers, and more than that, we need to consider the full life cycle of the products and the participation of different networks with different actors or different stakeholders at the different stages of the product life cycle. Another topic that is often mentioned is the acceleration of manufacturing and the introduction of the so-called exponential technologies. This means that entering in the industrial sectors of a new set of actors that were not so usual in these domains, especially in manufacturing, like people from artificial intelligence, from additive manufacturing, from sensing, from cyber-physical systems, and so on. And we need to also consider these new actors and new forms of collaboration that are brought in again by the new technologies like virtual reality, augmented reality, mobile computing, and so on. In terms of the digitalization of products, of course, we all understand the needs to educate our students to understand the importance of digital models, but also the importance of smart products and the fact that these smart products are built by a network of stakeholders in which each entity adds partial value to the product. So it's a kind of stigmatic form of collaboration. Finally, for the new business models, we can talk about aspects like co-creation, co-innovation, local enterprise, servitization, that Klaus Dieter also mentioned before, hybrid value chains. So all these new or emerging business models strongly rely on the notions of networked and collaborative perspective. So I believe that our future engineers need to have a strong basis on these aspects. But one important thing is we should avoid to fall in the trap of having new technology courses for each new fashion technology. In other words, our students should be educated to understand the cycle of evolution of technologies and to understand that technologies evolve very fastly. And for instance, this hype curve of Gartner is a very interesting concept to give to the students. So we should avoid this gap, and instead, when we think about the transformation of our courses in terms of topics to introduce, we should think more of the foundations. So some examples that I could suggest, again, under this perspective of giving them some background in computer engineering to understand digital transformation, I could mention like systems integration to give them a systemic perspective, collaborative networks. As I mentioned, I consider it as a very important pillar in all 6 dimensions. Data analytics and machine learning, that is a very important subject. Distributed manufacturing systems, simulation, in addition to other more classical topics like robotic systems, smart manufacturing, and of course, all the typical subjects of each program, if it is mechanical engineering, industrial engineering, automation, or electrical engineering. Then finally, at the 3rd level of education, PhD level, I also I consider that this is an extremely important mission for the universities, that educate engineers, is to train doctors in engineering. And in addition to the typical research work that PhD students do to perform their thesis, I also believe that it is important to have in the PhD programs additional courses designed to give these high-level students specific skills. These skills are, of course, different, but related to digital transformation, I could also mention again things like advanced topics in collaborative networks, advanced topics in robotics and manufacturing, advanced topics in industry information systems, entrepreneurship methods to help them to understand the value creation and how to create value out of research. And as a support for all of this, it is fundamental that our PhD students get a strong background in scientific research methods and techniques. Complementary, most of our universities, or all of our universities in our research groups, we also contribute to train young researchers or postdocs. And very often, postdocs are involved in research projects, but many universities do not offer them a well-organized training program. So I also believe that it is important to organize a kind of formal training program for the postdocs in engineering. And some examples of the things that could be included in this training program would be project proposal preparation, industry academia project management. It means management of research projects in consortia with industry and academia, team management and leadership, road mapping techniques, namely for technological road mapping, science and research road mapping techniques, technology assessment techniques, technology transfer and intellectual property, and of course, at the individual level, how to manage their careers. And a good example in Europe is that we have this Marie Curie program from the European Commission that puts a lot of emphasis on creating opportunities for this high-level post-education of young researchers. Finally, I would like to emphasize that besides the technical skills, and I only emphasize the computer-oriented and collaborative networks-oriented skills, there are other non-technical skills that are fundamental for future engineers. I think that Klaus Dieter mentions some of them, or many of them. I would like also to emphasize the need to introduce in our engineering education programs ethics. Engineering and research ethics is a fundamental topic nowadays. Responsible research and innovation is a kind of wider umbrella that can also include ethics, but also understanding of our responsibilities before the society in general. The introduction of communication and introduction and development of communication skills and internationalization. So in Europe, all our programs are very strong in this aspect because most of our post-graduation students are involved in European collaboration projects. So we are naturally in contact with colleagues from different countries and so on. Perhaps in other continents, in other countries like in Brazil, this is something where you have to put more emphasis. And from my experience of interaction with Brazil, I believe that we have to also put more emphasis on languages, namely in terms of training in English for your future engineers. And finally, I believe that it is very important that we can educate our engineers to be actors with a collaborative culture. So they need to understand that they have to work in contexts of networks and that they have to learn how to collaborate with different people from different backgrounds, from different fields, and even from different geographical locations with different culture, different objectives. And my last message is that our students should also be made aware of the main societal challenges that emerge every day in the time that we live. And one example is just this United Nations Agenda for 2030, where they identified a very important set of challenges that are driving a lot of research and development activities around the world. But giving this conscience of the importance of addressing not just our technical things, our technical developments, our algorithms, our electronic systems, our mechanical systems, we have a responsibility before the society, and we have to understand our role in the society and the scope of these bigger challenges. So this was my message about this topic. Thank you.
Right. Thank you very much, Professor Luis Camarinha. Also very insightful things. So it will be, let's say, a good collection of thoughts to be discussed afterwards. Now I'm going to introduce Professor David Romero from Mexico. So once again, thank you very much, David, for accepting the invitation. So you can start, be my guest. So you can share your slides.
Bringing up the slides. Okay, so today I would like to share with you two things. One, I have together with Klaus the opportunity to work in this foundation called the World Manufacturing Forum. So last year we developed a report on skills for the future of manufacturing, which I think is very relevant for our discussion today, to share with you what came out from these study that we conducted. It included 11 countries, 5 continents with 40 plus expert interviews. There's a collection of case studies if you would like to go and see the report in more detail. And later on, of course, a few words of what is happening with the new educational model that it's being launched at my university, called it Tech 21, trying to address some of the challenges that we are going to be discussing. So let's start just with a couple of numbers and the challenges that we have ahead in terms of the famous skill gap, right? And what we're seeing nowadays, there is a big discussion about the lack of focus on training, the lagging of educational system, particularly there's still this vision of dirty working place in when it comes to manufacturing jobs. But of course, this has been changed. Actually, factories are extreme clean places. The huge opportunity that we have to bring underrepresented populations into the workforce. I think women, particularly in manufacturing, we need to take more of the value that they can add. There's a lot of reports that say that actually if we achieve gender equality, that would represent 2 points of the GDP of a country if we are actually being more inclusive about, using the talent that we have in our female engineers in the different industrial sectors. And also these put us to think in the different situations that we're seeing nowadays when it comes to skill shortage or skill gaps or skill mismatch that we need to address. So I think the biggest, if you look into the different reports, Manpower Group, for example, around the world that I have been seeing, the number of companies that are not finding the talent that they need, right, with the required skills, have been growing over the years. And of course, this has been increasing because there are new things to be learned, and we need to learn them more fast with the proliferation of the new technologies that the fourth industrial revolution brought to us. Of course, automation, robotics, artificial intelligence is not taking our jobs. These technologies are not taking our jobs, but are changing the nature of our jobs and the tasks and the type of tasks that we need to do within those jobs. And as a consequence, a lot of the job profiles are evolving, are becoming obsolete, changing, emerging new ones, which are requiring us to change very fastly our skill sets. And those skill sets are not technical, but also are social, as was mentioned. And furthermore, this is very important. I love the definition, what is the equivalent of Industrie 4.0 in Germany for the Americans when they talk about smart manufacturing. And I love their definition because they say that true smart manufacturing is the marriage between information technology and human ingenuity. And this part is really the key of a true source of competitive advantage. Any company with the right, resources, financial resources, can buy the technology from any technology vendor, but it's really your humans, your smart and skilled humans in the shop floor, which are the ones that are able to convert that technology in a competitive advantage. And there's a huge impact if we're not able to close really fast these skill gaps, because if we don't have the knowledge and the skills in our workforce, then we're not going to be able to get out the dividends that we expect from our technological investments. And you see here in the graphic, Brazil, it's mentioned it, right? There's a huge potential lost, a huge risk if we don't push. And this is also like a message for whole Latin America. If we don't push strongly the evolution of our training systems for the workforce that is already out there in the labor market, and of course, our educational systems, which are preparing the future workforce. So according to our report, what we found is what are those skills that we need to look at has to do with digital literacy, right? We need to understand all these new technologies that are coming out into the market that are maturing and how we can use them. There are some particular ones, such as also the ability to use AI and data analytics. We want to evolve into a society, in a smarter society, into a smarter workforce that we use data to support our decision making. The third one, it's creative problem solving, and also I think this is changing later on. I'm going to mention about that, changing from project-based learning to challenge-based learning, right? And driving our, workforce and our future workforce by creativity, by problem solving, by entrepreneurial mindset, which is our fourth skill that we're seeing that is going to be quite relevant. The fifth one has to do with the physical and psychological safety and effective use of technologies. We are humans and we create tools of all sorts. So of course we have been, developing technology for many centuries as a species, trying to make our work more easier. And I think this will continue. The only difference is that we have evolved from, the stick and the rock to digital technologies nowadays. Also mention it, right? We need to work together in intercultural, interdisciplinary manner, being inclusive as a society. We need to take, all the unique capabilities that every member in our society can bring to the table. And even nowadays, right, all what technology can bring, robotics, automation, artificial intelligence, the biggest, leaps in productivity come from this intercultural, interdisciplinary, and human technology collaboration. I think this is very, very important. But of course, as we create these new teams and we connect everything, trying to become smarter as a collective whole, this is of course also the vision of Japan with this concept of society 5.0, to try to create a smarter society that knowledge is really shared and it's a leverage to create better services for the society. Cybersecurity is going to be very important. Privacy, data, information, mindfulness. Number 8, the ability, of course, to handle complexity. It was mentioned, everything is getting connected. So we're arriving to an era where we're going to have systems of systems, and we need to teach people to manage this complexity and how to engineer these systems of systems. Effective communication, with humans, with IT, with AI systems. I mean, it's not the internet of the things, it's the internet of the things, services, and people. Everything is going to be connected. We're going to have partners in our daily lives, in our work. That could be a chatbot, helping us to do our work. So everyone is going to collaborate, and of course, open-mindedness. I mean, now we're seeing that the hot topic for next year is going to be, of course, resilience. And when we talk about also digital transformation, it's very important to talk about digital culture, right? And a digital mindset. And this refers to the openness, right, of the workforce, of the society, of exploring what we can do with technology to improve, our workplace, to improve our daily life. So this brings me to share with you a couple of emerging roles that we're seeing in manufacturing. These have to do, for example, with the digital ethics officer, right? We need to talk about the ethical use of data, the industrial big data scientists, because we want to unlock the value of data in these new industrial data spaces that are being created, the collaborative robots expert, not the physical robots, but also the software robots, right? Building new, more interactions with our new technological based partners. The Lean 4.0 engineer. I think every digital transformation, of course, starts with the transformation of your business processes. Technology would not fix your processes. So therefore, and the importance, right, when we talk about this magic triangle between people, tools, and technology, the key is people, right? And that's why we are so worried about closing these skill gaps and transforming really quickly our training systems and our educational systems, because without the proper workforce, without the proper future workforce, we're not going to get out those benefits, those potential benefits that technology can offer us. We have the part of IT, OT integration, which represents, for example, here, the convergence, right, of the computer scientists and the mechanical engineers. They've been working for many years in two different worlds. Now they need to work together. And of course, the digital mentor. We need to facilitate these processes, which, now that we have talked about the skills needed, the new job profiles emerging, we need to develop new tools to try to understand what is coming, to try to anticipate, to see, what is the degree of the skill shortage, and if we have skill shortage, what we need to do, because we don't have enough workforce. So do we need to invest more in automation? Because automation, for example, Japan is doing that because of the aging population. They're investing in robotics automation because they need to compensate those, lack of workers that are having in their society, or we have this skill gap, right? And we don't have enough people with the right skills level. So what we need to do on that, we need to push there, or we have a skills mismatch, right? Which means that we have enough workforce and it's trained, but it's not training in what the industry is needed. So for me, in this case, I always talk about that we need the cure, right? The cure stands for cross-skilling, upskilling, reskilling, and expert skilling. And this will also depend on what is the situation in your country, what is your situation in your company. Do you have a skill shortage, you have a skill gap, or you have a skill mismatch problem? And depending on that, you will need to apply a specific skill development strategy. And this skill development strategy need to be, also innovative. We need to accept. I think the medical doctors have been done it very well for many years in terms of the education. It's the new era. It's lifelong learning. We need to continue learn all the time. We need to find new ways to reach people when it comes to different platforms for learning. We need to make hands-on the learning. We need to come back to what Germans have been doing for many years, to apprenticeships, to recognize also as a society the value of technical education. We need, to sail a boat, you need captains and sailors. So not everyone can be captain. So what is the right mix between doctors, masters, engineers, technicians that we need to have in a society to be able to sail the boat of our economy? And of course, as we talk about Industry 4.0 technologies, how we also can use those technologies to make more exciting the education process. So here's some specific examples, right? I mean, in terms of different initiatives, depending what are your objectives. I think you can read faster that I can speak, but you see what we need to do in terms of upskilling, reskilling, or training our future workforce, right? And many points, for example, when it comes to education, have already been mentioned. We need to revise our curriculum. We need to think in new degrees. We need to make more hands-on the education. I think theory and practice both are important, but as always, the challenge is in finding the right mix. And what would be, the recommendations that we can provide? We need to create a manufacturing market with a lifelong learning mindset. We're here to continuously learn every day. We need to increase the investment in the workforce education to reach the full potential of the new technologies. This was already discussed. We need to enact policies to promote monitoring, to promote manufacturing workforce education and training. Right? I mean, we need to invest in that. We need to create incentive for that, for people to continue be trained and to be redeployed. We need to excite people to pursue careers in manufacturing. I think this is the best time that we can have as I will be a student. I would say this is the best time to pursue a career in engineering, shop floors, supply chains, warehouses. Everything is becoming amazing with all the new gadgets that you're going to be wearing or interacting with. We need to develop new profiles with technical expertise complemented by the generalist know-how. So we're seeing more of these T and E-shaped models as part of the way of shaping our educational curriculum. The use of technologies to innovate the delivery of education and training. Support the social mobility through manufacturing, because we're a powerful industry that contributes a lot to the GDP of the countries and therefore to the prosperity of the society. We need to ensure the relevant skills are being taught, right? So this is, we need to give perhaps human resources department what used to be just a human resources management, right, and needs to be now human resources strategic planning and management, right? We need to look into the future, give human resources department more strategic tools to anticipate the needs of talent of the company. We need to elevate the values I was mentioning of vocational technical education and training pathways. We need to do this a lot in Latin America, because the best thing that can happen in a family is that the kid becomes an engineer, right? A prestigious engineer, right? But I think technicians, as in Germany, right, it's not that technician it's less or it's more than an engineer. It's not that a PhD is more or less than a technician or an engineer or a master's. Everyone have their own role to contribute to a sustainable, socially sustainable industry, a socially sustainable industry. And lastly, we need to foster collaboration to address the skills development needs between academia and industry. We need to do this. And just to finalize, because if I don't talk about my university, I will get into problems. Because of this, we have accepted that the new mega trend of education, it's learning to learn, right? So we think that it's not any longer sufficient to have a curriculum based on project-based learning. Now we're having this new transformation of our educational model that we call Tech 21, and we're moving to the idea of challenge-based curriculum, right? So they will be forced to learn by different means. And of course, also that means that we need to provide more flexibility to the student, which also brings to a change in the relationship between the student and the faculty. The old professor model, just based on being a docent, doesn't work anymore. You need to be a research professor, you need to be a consulting professor, so you can really add value to the students with your experiences, because when it comes to knowledge, of course, there's the internet, there's the book. So we need to change our relationship and tell the students that university is just the beginning of a new learning journey for their future professional careers. That will start, in our case, with an exploration. Then they will be allowed to be, select a couple of courses to start focusing where they want to add value, how they want to add value, and by specializing in a specific area, always pursuing this T-shaped model, right? Having enough general knowledge to work in an interdisciplinary environment, to have those communication skills at social and technical level, to talk with, the mechanic engineer, to talk with the computer scientist, to talk with the, mechatronic engineers, with the robotics engineer, and so on. So this was what I wanted to share with you today. And thank you very much once again for the invitation.
Thank you very much, David, for a very nice talk. And you have presented some very, let's say, good stuff from the World Manufacturing Forum. So it's very nice to, let's say, to share this with the audience. So thank you very much. So then I'd like to invite Professor Ubirajara Moreno from UFSC for your speech. So please be my guest.
Okay, is running YouTube?
Not yet.
Estamos aguardando que apareça lá.
Just a moment. Yes.
Ok, tranquilo.
It's good.
Okay. So thanks for the invitation to represent the program of automation systems course in this panel. So my point here is to introduce the concept of artifact and see what this concept could put some light in these important questions in the education of the engineer of the future. So the title of this short talk is Industry 4.0 as an Artifact, new challenges for human-machine interaction and education. This study was a part of my sabbatical that was funded by CAPES Print last year in the University of Paris-Saclay. So I made a search on the internet about some images or figures on Industry 4.0 and digital transformation. And I found these images. There are many others very close to this one. And what is for me is interesting in these images, in these graphics, is that the role of the human is not very clear in this digital transformation. We don't know if we will share the decision-making process, or we are just applying these tools or monitoring these tools. It is interesting to see that we interact by using the hands. This is very interesting. And sometimes with cell phones and tablets and so on. And another thing that's interesting in this visual presentation is that the digital future is blue. The majority of the images are in blue and black. And then I pursued this search, and then I found that this is the preferred color of the tech industry to present their brands, so dark blue and black. And what means this choice of the blue to represent this digital future? So there are some concepts and emotions related to blue, and I will keep in all these emotions and concepts the intuition, freedom, imagination, inspiration, and intelligence. So, and keep in mind these characteristics, I will follow my presentation. So here we have some properties from the Industry 4.0 that some of them were already presented in the previous talks. So I will talk about them again, because I will use these concepts when I will talk about the education. So the major properties, or the most important properties in Industry 4.0 are the questions regarding the network structure, integration, interoperability, virtualization, so the role of the digital twins, the customization, the term smart, that is related to the human-machine decision-making, the concept of autonomy of the equipment, so we will have cyber-physical systems with the capability and the skill to make decisions, and also the question of collaborative intelligence. In the second of the presentation, I will try to see how these concepts and properties could impact in our vision of education. But let me introduce the concept of the technological artifact. So this is a concept that is from philosophy, and in philosophy is a traditional studies from technology. The artifacts are simply defined as objects made intentionally in order to accomplish some purpose. And they must have three properties. They are intentionally produced, they involve modification of materials, and they are produced for a purpose. In the case of the modification of materials, nowadays we have some systems that we could classify as an artifact, but actually they do not involve the modification of materials. They are systems. So we have systems that could be classified as artifacts. But how this notion of artifact could help us to understand the impact of the Industry 4.0 in our society. So the role of the artifact is classically divided in philosophy in two main purposes. One is called normative. So the artifact as an instrument, a tool. So we design a tool, an instrument or equipment to interact or to make something in the world. This design is made with a purpose, to make something. But the second role of this artifact is a consequence of the usage of this artifact. So the usage of the artifact actually constrains our action. So once this artifact is created, our action in the world will be performed by applying these artifacts. And these artifacts, they have constraints and they have possibilities. But the fact is, once this artifact is created and applied by the human, we start to think through the artifact. So when we visualize the action that we must or we want to perform, we start to think with the help of the artifact. So now what is possible and what is not possible is given by the possibilities of these artifacts. So the humans could start to use these artifacts in their cognitive practice. So we start to think our action considering that we will act in the world by the artifact. More recently, we have also the concept of the extended mind by Chalmers. So the mind in this concept extends beyond the brain and the body. It encompasses the environment, and in this environment, we have not just other people or nature, but we have also the artifacts. So these tools, these technological tools like smartphones, computers, and so on, are parts of our cognitive action, are parts of our mind. Some say that there is a extended consciousness when we use this kind of artifacts. So, since we have this interaction with our mind, with these artifacts that were created for a purpose, but right now, by the use, affect our vision of the world, the presence of the artifacts change how we relate to the world, change how we see the world, act and produce science, and how we interact politically, and how we interact in our society. So considering that the Industry 4.0 is a technological artifact, actually there are many technological artifacts that integrate in the Industry 4.0. My point here in this presentation is that the Industry 4.0 and the digitalization process that we will experience will change our perception of the world, will change the way we think, and will change the way we construct knowledge, because knowledge is constructed by experience and by analysis. But this experience will be affected by all these technological artifacts that constitute the Industry 4.0. So we will look at the world in a different manner. Now, bringing back the properties from the Industry 4.0 and now thinking as an artifact, the question now is how to think education in a 4.0 perspective. Since we will see the world in this paradigm, how this paradigm will affect education. There are many effects in education. Are they all desirable or not? So networking is important, integration, interoperability, customization of the formation of the engineer, virtualization. So when acting in equipment in a laboratory, is this equipment real or virtual? This human machine decision making, this is smart. How we will consider this in the formation? What about autonomy and collaborative intelligence? So, regarding these properties of Industry 4.0, we have some issues to address in education. The first one, I think, is the question of human-machine and human-human interactions. In many papers, we see that there is a claim for an anthropocentric vision of the human-machine relation. We could also extend this anthropocentric to an ecocentric vision. So how human and machine will share decision, they will interact. It's good for the human, this interaction. We will preserve our characteristics or characteristics that we would like to preserve. What about the balance between intuition and analysis? So the question of correlation and causality. Today we are applying artificial intelligence or machine learning to a lot of problems, but sometimes we are nowadays more connected to questions of correlation than to causality. So for causality, we need to understand the process, the relation cause effect, not just the statistical properties of correlation. What about the decision making? How we will construct systems where a human will take a shared decision with a system? The case of airplanes is very, very important today. Where is the control of the human? How far we will go with the human decision and how far we will go with the system decision? The impact of the black box approach, sometimes the fresh students or even the students in the more advanced stage of the course, they are using algorithms. They don't know what they are doing. So this black box approach, and if the result is satisfactory for me, could lead to some problems about the conception and the accountability of the systems. In this new perspective of formation, algorithms and data analysis play a central role in information. So we have a formation based today in math and physics, but sometimes maybe we will need to increase the role of data and use algorithms to describe the nature and the world. Another consequence that will impact maybe in the infrastructure, for example, what is the role of the classroom in this digital world? We need to be at the same time, at the same space to receive a class, to be exposed of experience of constructing knowledge. Here, all around the world, here in the pandemic, we are questioning the return. How important is or not the conception of a classroom? Another paradigm from the Industry 4.0 is the product-driven process. Now, who is driving the process is not the teacher, is not the institution in this view. Who is driving this process is the student. And we must think about the decisions made by the students in this process. What's the meaning of a curriculum? What is the meaning of a master-disciple relationship in this digital world? Could augmented reality and digital twins be applied to the formation of new engineers? How these artifacts will change our relation with the real world? And we could not forget that we are treating with social technical systems. So the students must have the instruments to analyze the relation of what they are producing with society. So for me, one important point that was pointed out by Professor Camarin and Professor Romero is the question of ethics. I think that ethics play a central role in the formation of the new engineer. So to evaluate the impact of the products and process in society and the individual in nature, not just the benefits of the profit, but also how these new artifacts could affect humanity in a whole sense. To think about common values and rights. So we are now tackling these questions when we discuss about AI. What a Chinese think about common values or rights different from the European, and is different from an American or from a Latin American or in Africa. So what will be accepted or not in these new platforms? Another important question regarding ethics is the question of authority. So who is the other? The other is it's a person, it's a machine, is a system. So maybe we could lost this capability to know how from who we are addressing some discussion, which are the partners in a decision-making process. So in the last, I think that in the formation of the new engineers, we must specifically address the question of the ethical aligned design. So the ethics is a question of design. So in the stage of design, we must think about the impact of the product in nature and in society. So to make a final remark, I think that we need a new awareness in engineering education, going beyond just the technical subjects, because Industry 4.0 and the digitalization will affect our perception of the world. And we must be aware of this consequence to take the good results from Industry 4.0, what is good, and to avoid the bad consequence. But to do that, I think that we must discuss in the engineering formation what is to be human and in which will be our place in nature. So, thank you.
Thank you very much, Professor Birajara, for your nice talk and philosophical, let's say, point of view. It's very important, actually. I'm quite suspicious because I'm a fan of this, let's say, perspective, but perhaps we can have some time to discuss about this afterwards. So then, finally, I have the pleasure to introduce Professor Enzo Frazon from the Department of Production Engineering from UFSC. So thank you again, Enzo, for having accepted the invitation. So please, you can start.
Just inform if you can see my screen.
Not yet in the YouTube.
Estamos aguardando, deve carregar.
Yeah, all right. So we are, yes, we're ready. So you can start.
So thank you very much for the introduction. It's quite challenging to speak after Tobin, Camarin, Matos, Romero, and Birajara, but I'll try to do my best to, in 5 minutes, shortening my initial plan, to talk a bit about the role of academia in Industry 4.0. Basically, we'll provide some context. I'll talk about the competences expected from future engineers and how the university can support the building of these competences. So basically, I'm not talking about this again and again, but we have to understand that we are facing several challenges in this fourth industrial revolution. We have a broad range of technologies, the connection between digital and physical worlds, connected networks, integration of production systems, complex problems to be handled by the future engineers, data-driven decision-making, and all of this supporting industry competitiveness. So we have several barriers as well that need to be addressed. And one of them, and it was very good to hear the study from Professor Romero, one of these barriers are related to human resources. So how to create this future generation of, I would say, super engineers, because they need to be good in engineering and they need to have good skills as well in computer science and also good skills in social relationship. And can you see that's really a new kind of engineer, an engineer that you have to cope with very complex problems that are arising due to the new industrial revolution. So, which should be the focus? I would like to stress that the focus really will be in the blue part. I also am a blue guy, and I'm very happy to hear that Industry 4.0 is blue. This means that I'm well placed. So we should focus on the development of capabilities, creativity, empathy, communication, assessment, critical thinking, versatility. Because the red ones, the red capabilities will be taken, these skills will be taken by the machines because they can do it much better than us. So some prerequisites for this new engineer. First of all, a positive attitude towards the future. This is very important, and I always talk to my students just arriving at the university. You need to think in the future in a positive way. This is the first thing. Long-term orientation instead of short-term. You need to invest your time so that in the future you can perform better. Self-motivation, very important. Remember, this all prerequisites. We are then arriving at the humans at the center, and then we need to have a future engineer, a future professional that is flexible to adapt to the new challenges that are arising, that is able as well to handle different technologies. We still don't know, we still don't have a full picture of what will come in the future, so we need to adapt to different setups, different technology that will arise, and also complex situations. We have systems, and Professor Tobin explained it very well, that in the past everything was stable, and in the future everything will be dynamic and very complex. So, central thing for the future engineer, the future professional, is learn to learn. I recently heard this from the president of the board of FEG, Décio Silva. He said that during his time as the mechanical engineer at UFSC, the most important thing that he learned was how to learn, continuously learn. This is the main thing I think we should teach to our future engineers. So this slide, in Portuguese for sure, I present to the students just at the first semester. I show to them two options. First option, you can cope with the requirements and become a good professional. This is one option. The second option is actively search for competences, mindsets, and experiences which will prepare you to transform the future. And depending on this choice, you will take part in two different groups. The first group, the group of individuals whom will revolutionize industry, services, economy, and the society. Or you will be in the group of individuals whom will be affected, and most importantly, will be negatively affected by the revolution, which will be led by the members of group 1. This means that we need to actively search for competences, mindsets, and experiences which will allow them to take part in the group 1. There is, at the end, I showed to them, there is no option. You need to do your best to take part in the first group. So, which will be the skills of this engineer, the super engineer of the future? Solid technical training, for sure, but also Competences to identify and solve problems. This is a very important thing for engineers. Solving problems is the central part of engineering tasks. Ability to learn independently, keep up with technological advancements, concepts, technologies, methods, profit from opportunities. The university is a very interesting environment where the student should really take advantage of the opportunities. Taking part in groups, scientific training, apprenticeships, projects, voluntary work, and very important thing to create during this time at the university, create a portfolio of achievements. Because at the end, in the future, to get a good job, to be competitive, you have to show your achievements that you already had. So instead of a curriculum, you have to show the achievements and how you achieve these results. Also very important. And finally, interpersonal relationship, communication capabilities using different media and languages. Okay, how the university, first the competences. How the university can support and help these future students. We first need to attract the most competent and capable individuals. There is a very huge issue of attracting engineering and computer science sometimes are not so attractive anymore for young people. We have to work on that, in my point of view, not only in Brazil, but everywhere. Provide a good environment where they can flourish. Support. The university should be very supportive to these students. Mentoring is a very important issue in my point of view. Bring the industry to start mentoring the students still in the university. There are some initiatives on that. Foster curiosity and experimentation. So more general and now more specific. Keep the curriculum, the obligatory curriculum to the essentials. What is really important to provide solid technical training. Foster a systems-oriented training. This means since we will have to deal with very complex systems, we have to, since the beginning, since the university time, try to foster a systems-oriented view. Motivate project-based learning approaches. Place the student at the center of the learning process. This was explained by the presenters before me. And also, it's very important to stress, increase the availability of optional disciplines. And this means allowing students from engineering, production engineering to make computer science courses or automation courses so that we have these possibilities that one student can profit with. This is not difficult to do. It can be done very easily, in my point of view. And foster opportunities, student groups, scientific training, apprenticeships, projects, voluntary work. So make the life of this potential engineer, potential professional in the future, making the life of this student contribute in a good way for his professional future, or his or her professional future career. So very briefly, in 5 minutes, I try to explain what we think is the whole of academia in Industry 4.0. Basically, we really need to be very supportive to this future engineer, future computer science, that we will have to cope with these very challenging times in the future. Thank you. And I'm looking forward for discussions, even though I don't think we have much time.
Thank you, Enzo. Yes, unfortunately, we shift to abbreviate quite a lot our discussion because we took a longer time that we planned to set up the time, and actually I didn't expect that 15 minutes time that were used to present that movies, etc. So I didn't know about it. So anyways, I know that I was already advised that we should close this section, let's say, quite soon. So my just proposal, so in a very pragmatic way, unfortunately, we should, let's say, follow the rules. I will make some, let's say, just some highlights from the 5 talks that you had, and then I would like to invite you, let's say, each one just to give a final word about this, let's say, this general theme and the general challenges, and then perhaps
some let's say advice from you. Let's say you are very experienced people, let's say, which who have working on this area. So then you can close the session. So then in this sense, first of all, the points that I would like to highlight, trying to make a kind of compilation from all of you, and perhaps this could be, let's say, a good hint for next, let's say, reflections about this. So it comprehends, for instance, the complexity. So I guess especially Professor Camarin and Klaus Dieter mentioned or emphasized quite a lot, and I think they were very happy to show how this in fact is important in the near future. I mean, for the future engineers. I guess that all of you have mentioned about the so-called holistic education, and well, it's a kind of nightmare, because there's so many things that new students should learn. So including economics, ethics, social things, sustainability, etc. And I wonder to know how many years, let's say, the engineering course in the future should take perhaps 10 years to learn about all these issues. But for sure, it's clear that from your points of view, how, let's say, how we should evolve from this, let's say, to provide a more, let's say, comprehensive background to our students, and not only from the technical perspective. Several of you mentioned about collaboration. I guess implicit perspective or feature that should be somehow provided to these students, and in the way they design the systems, the solutions, they interface with customers, with the different stakeholders. So collaboration is almost embedded in everything. So somehow this should be taught to the students. I like very much when Klaus mentioned about their dual system. So I guess it's a very nice experience. Perhaps we can, let's say, take advantage of this to somehow learn from this, because, for instance, here in Brazil, this dual system to some extent exists, but well, for sure it should be improved quite a lot, because this dual system is still separated so far. So it should work, let's say, more smoothly and integrated. For instance, and David mentioned about the, let's say, there's not enough people, so population is aging. In some countries, populations is even decreasing. So new competencies are emerging. The notion, or perhaps the re-evaluation of the vocational, say, tests perhaps is very important. Perhaps to cut the time, let's say, young people spend to try to see, okay, to which engineering course or even which profession they should follow. So because sometimes I could see that young people are somehow lost, let's say, in the middle of so many courses, so many technologies, etc. Learn to learn. I guess this is one of the must. And Enzo also, let's say, mentioned this. So how to teach students to learn how to learn. So how we should adapt our pedagogical methods to teach them about this. I like very much the thing that David mentioned about the challenge-based curricula. So perhaps it's linked to what Luis and Tobin mentioned as well, about, let's say, the way we have to construct the new curricula in terms of more flexibility, more integrated with industry, more collaboration, project-based. So students should be somehow challenged. I appreciate quite a lot, let's say, the philosophical perspective from Ubirajara. Yes, you are. I guess you are very right in my point of view, because everything to some extent depends on how we see the things. So we are somehow in the fashion of Industry 4.0, and sometimes it's quite important to stop and to see from, let's say, from a wider perspective what we are doing with the so-called artifacts, with the cyber-physical systems, technologies, etc., etc. And because behind of everything, we are there. So there are people, we are, let's say, somehow heading the wave and conducting the flow of the evolution. So to some extent, everything depends on our point of view. And all of you also mentioned about the ethics. I guess this is one of the must nowadays, ethics. And so how the information is set, because people are talking about, real-time information gathering, etc., but sometimes they forget that nowadays, or at least from now on, this would be somehow almost forbidden. Lots of data from operators, shop floor, customers, etc., well, should be somehow forbidden to be caught. So how we should handle this. And I like very much also when Enzo mentioned about, so perhaps this is quite linked to what's the role of the new university. Somehow is to give support, mentoring, etc., instead of only be, let's say, based on, let's say, hard skills or something like that. So before I finish and pass the word to all of you, I'd like to express my deep gratitude for your time. I know that your agenda is are impressive, are fully booked. So thank you very much for your attention, for your time that you have, let's say, prepared the material. So then I'd like to invite you in a very short, let's say, time to give, let's say, your last talk, or let's say, statement to finish this event. So we can start by Klaus Toven.
Yeah. So yeah, thank you very much for this nice summary. I think really well done. And in the beginning, I thought I'm a bit provoking, but I was not too provoking, because many of my arguments popped up in the other presentations as well. So when listening to all of you, one thing came up in my mind. Our university is, compared to other German universities, quite young. And we started with a concept without, let's say, having groups and without having single offices. So all the professors...
Oh, I'm sorry.
All the professors were together in an open space, and there was no fixed curriculum, and the curriculum was designed based on projects, and the projects were lasting for 1.5 years up to 2 years, and all the subjects popped up were part of the classes in the projects. And our university was, for a couple of years, it was said, oh, the red university in Germany, because it was in conflict with all the traditional concepts. And for example, in computer science, still 50% of the classes are project-based, 50%. And we have a very good reputation, meanwhile, based on this experience. Because meanwhile, many other universities went into this direction, and they have very, very intensive projects in their curriculum. And I think this was more or less the same direction, which I can anticipate now for the future. Because the professor, the teacher, will be more a mentor, and there is no fixed curriculum. Instead of, or let's say, just in the beginning, of course, we have to lay a foundation, but everything else depends on the needs and the challenges, as David, for example, said. And so we have to guide young people into this new world where they have to be successful. And this is also what I meant. How can we inspire young people to, let's say, to take care of things which they which are hard to understand for them? Because many of the industrial problems are far away from these people. And we have to bring these talented people into these let's say, ideas into these dimensions and into these worlds, into these challenges. And this is, I'm still happy that this is more or less the outcome of this, because because this is also I'm totally convinced about necessary changes. And as I said, my last comment in my presentation was that we have started this discussion in our faculty, and I was very happy that there's a consensus between all the colleagues that we have to go this way. So thank you very much.
Thank you very much, Klaus. So Professor Luis Camarinha.
Thank you very much. So I also think that we had a very good set of ideas that were, I think, quite complementary.
Yes.
And in general, I could agree with all of you. I didn't hear anything that made me react badly. So I think the ideas are all very interesting, very, very complementary. And if our challenge today was to assemble a group to create a new Industry 4.0 engineering degree, I think it would be a very interesting challenge. I think we would have all these ideas as a rich starting point. But what worries me more is not our capability to develop a new program. What worries me more, what I think it's a main challenge for most of our universities, is that we have existing engineering programs. And these existing, let's say, traditional engineering programs in different fields, for many years, they will continue educating people and launching in the market thousands of engineers every year. And the reality is that although we can find, let's say, pilots here and there about new initiatives, we cannot forget also the traditions, the bad traditions of universities, like departments, like owners of programs, and also engineering associations that in many countries are the ones that give the title or the right to have a job as an engineer, and that are quite conservative in terms of the titles and the programs. So I can imagine that for at least a number of years, we will have the traditional programs. So that I think that the immediate challenge for us is how to transform those existing programs. How can we modify them to make them more coping with the real challenges that we have? And I don't believe that we'll have only one type of engineer, whatever title we give it. I believe that we will continue having different specializations of engineers. So all of them will need some transformation. And I believe this is a challenge for each one of us in the departments that we are with. So I think all of these ideas are very important, but we should not forget also the current reality and the need to transform what exists, because it is what generates thousands and thousands of engineers every year. So thank you, Ricardo, for the initiative.
Yes, thank you, Luis. So we have a kind of legacy system to
yes
to be dealt with. Yes. So Professor David Romero.
Yeah, I mean, I will build up on the previous comments. I mean, yes, universities are one of the last standing, let's say, sectors in society or industry that have not been disrupted. We have been starting to be disrupted, and some universities have been resisting. I think it's beyond just, revolutionizing our educational programs, our curriculum. I think we need to rethink what is a university, what should be a university to the 21st century. I think for me that a university is the place where we learn to think, right? And this is, more than trying to give a degree, a label, and say you are engineer X, right? What we need to do is to teach students to think, to learn. And actually, I would like to finalize, taking, Enzo mentioned it, taking also a quote. It is actually from Alvin Toffers, that he says that the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn again. And I think this is the role that we have as universities. We need to perhaps, go back a little bit to the old philosophy of the Greeks, right? And as I was saying, we need to teach our students to think, and we need to give them the tools to learn and to unlearn and relearn again. And I actually also, many of us were scientists, and I think that's what we are passionate about, right? I mean, that's actually what our PhDs, for example, mean, right? We have been trained to think using the scientific method, and we can apply to anything to try to discover new facts about nature, about systems, about people, depending from which, discipline you come. So that's my takeaway from this discussion, and also that's my homework for our audience. It's time to rethink what is the role of the university in the 21st century.
Yes, by the way, I totally agree with that. So thank you very much again, David, for your presentation, talk and your time. So Professor Birajara, so your last words.
Thank you. Just a last words. I think that the digital revolution will affect all the human relations, and a formation that is just a tech formation is not acceptable anymore for society. So our stage of knowledge about the impact of the activity from engineering, and starting that point, not anymore acceptable to not address the question of the impact of our actions in our products and society. So society demand it's from us. We must respond to this demand. Thank you.
Yes, yeah, you're right. They should complement the new stuff on top of this. Yes, good. Thank you very much, Professor Birajara, for your time and for inspiring, let's say, lecture. Professor Enzo, please be my guest.
Very briefly. I think my statement will help understand how we could change university for coping with the challenges of the 21st century. I think the graduate programs are capable, and I think we should start by revolutionizing the graduate programs. In our case, in Brazil, is master and PhD. Implementing these new things that we think are important for preparing the engineers of the future. I think we should start with the graduate programs, masters and PhD. So because the barriers are there, but are less tough than the ones from the undergraduate courses. And I think by showing the positive results that we will achieve, we will convince also the undergraduate courses to revolutionize, to work as the main force of change. I think this is my main message. And for sure, Merry Christmas and Happy New Year for you, if I don't see you in the next days. Thank you.
Thank you very much, Enzo. So towards closing the session, I'd like to thank you, all of you, once again, and I'm sure it was very inspiring, because as Camarilla said, there were several, let's say, complementary points of view, which is very good, at least when you are in university, so people can share different, let's say, visions, perspectives. So this is the university, so different, let's say, pieces of knowledge and experiences, visions, and I guess, let's say, we leave from this session quite, let's say, excited, let's say, to provoke new changes, new movements, and perhaps this is the most important outcome that you can, let's say, expect from an event like this. So we are eager, let's say, to make some changes. So once again, thank you very much, and I hope to see you, let's say, perhaps in the next panel. So, bye-bye.
Thank you.
All right, thank you.
Dentro de 5 minutos começaremos a mesa institucional.